Thank you, everyone. Right, so we're almost at the summit. Oh, tough crowd. It's a good thing I prepared 10 other summit jokes. It's going to be a long talk for me. Right, so we started, you know what, yeah, who wants some candy? All right, here we go. I think I can throw better than our other presenters. Okay, this is getting dangerous now. All right, so we started our climb to the summit earlier today, and then continued this afternoon with a nice introduction to AI native apps. We talked about building and operating MCP servers, and then we switched over to securing those MCP servers with a really cool talk by Jared, and then moved over into just seeing what Vandana did with exposing some of those real-life threats on the LLM-based applications. I'm going to switch over and talk to you a little bit about what Snyk has been working on. We have 4 live demos to get through. I have 2 other colleagues joining me for those. So today we'll answer the question, what happens when you get a bunch of product managers to do live demos? And yeah, maybe we'll be successful. God, really tough crowd. I thought these jokes would kill. All right, so what I'll do is I'll talk a little bit about, I'll take you through a climbing journey. Hey! I'll take you through a climbing journey of AI security. We'll start with discovery, take you through our AI bomb product, move over to understanding security risks, and intro our new AI risk database that we've been working on. Just show you a quick, very experimental preview. And my colleague will join me on stage. We'll use his vocal cords one more time. Hopefully they hold on. Krish will take us through the red teaming and show you real-life adversarial attacks. And then we'll end up with tying it all together to show you how our new AI security platform can help you centralize and operationalize your AI security program with Evo. Right, let's get started with AI Bomb. So in today's day and age, as we've seen, AI apps are everywhere. AI is no longer a thing that's just part of a feature. It is essential to the way an application works. As such, there's new threats that are introduced. There are new components that are being introduced through dependencies, through any sort of imports that traditional SBOM tools or traditional tools, security tools, just don't cut, right? And it's really, really difficult for you to secure things that you just cannot see. So that's where our AI bomb, AI bill of materials, it is really difficult to say AI bomb without making it sound like an AI bomb, but I'll try my hardest not to. Another joke that didn't land. Wow. It is end of the day, and I am standing between you and drinks, so I realized that. Right, so earlier today, you've set up, I think, a Snyk free account in Snyk CLI. So you can follow along if you want. If you open up your terminal, you can use this on any repository. It's live. Here are some quick commands that you can follow. You can auth. You can hit the help command to see what options are available to you. Just make sure when you're running the AI bomb, you include the -- experimental. There's a couple of options. You can either export to a JSON. You can make it pretty with JSON query if you want, or export to an HTML and enjoy the nice interactive view with your AI bomb data in an HTML page. Right, so let's do a quick demo. And this is a live demo. Can everybody see my terminal? Is it big enough? It's big enough.
Make it bigger.
Make it bigger. I'm not allowed to joke about that. OK. Let's start with an auth. So generally speaking, you get redirected. You grant access to the app. Voila. And then we move back to the should be. Come on. Come on. Let's assume they were authenticated. Right, so for this demo, we're using AI Buffet, which is a repository that we built. It's a Python-based repository that contains a bunch of different features, including something like a chatbot, image processing, text embedding. And you can see some of the files that we have in the repository. Right now, AI Bomb, it supports Python scanning. That's where most of the applications are being built today with AI native apps. But we are going to be moving towards TypeScript support shortly as well. So that's coming at some point. For this, let's actually take a look at the requirements file, because this is going to be an interesting bit for us. So you can see here four requirements. And when you look at these dependencies, you're maybe thinking to yourself, this is a pretty simple app. There's not too much I have to worry about in terms of security components or any sort of external dependencies. But if we actually take a look at what our Snyk AI bomb finds, it's a different story. And to run it, it's simple, -- experimental. For this, we're going to actually export to a JSON file. It takes no time to run. It's using our SAST scanning tool, Snyk code in the background, to put together all those dependencies and identify all the AI components that we find in your repository. So you can see the scan is fairly quick. Granted, it's not a big repository, but it was less than a second, I think. Right, so let's take a look at what we found. So out of those 4 dependencies, we have about 47 components. We have 23 data sets, 10 machine learning models, and 9 applications and 5 libraries. That's quite a bit of a discrepancy, right? And this is kind of what I get to when we talk about the difference between traditional tooling and the need for this new tooling. We really do need to step forward and make sure that we're using the right tooling in this new day and age to be able to identify all these components and issues that are being introduced. One other thing I want to mention as well, one other example I want to take you through is let's take a look at one of the chatbots, our chatbot application here. And the reason why I'm showing you this is there's a little bit of depth that we need to explore when it comes to model initialization or looking for these AI components in your code base. So in this example, you can see on line 18, we're initializing the Claude model, but it's actually being loaded in a different line through a variable. So because we're using our SAS tool, we're actually able to follow along and, and find the actual, all of the instances where the model is being both loaded and initialized. So for example, if you see here, we're able to see that, yes, indeed, we're finding it on both the line in which it was explicitly called, but also the line at which it was called through a variable. So again, we're able to do that through a data flow analysis, which is super helpful in large enterprise code bases where, model definitions get obfuscated through dependency injections. They live maybe in different files, et cetera. So this really allows you to see all the instances of where where we're finding that AI component. And here as well, we're also finding some of the libraries that are being loaded and imported. So for the purposes of this demo, it's very brief. This is just scratching the surface. Please feel free to try this in your repository, and you'll be able to find all these things there today. And yeah, thank you for this one. So we are going to move over to the second part of our climbing journey. Right, so on our way to the AI security peak, yes, thank you. Now that you have visibility into all the tools and all the AI components that are in your code base, the different problem is to actually understand them. Today, we don't really have a centralized CV database for AI risk. It just doesn't exist. You can probably find it if you look hard enough in a million different places, but who has time for that? So what we're building is an AI risk database that centralizes the risk information that we find across a bunch of different places and use our own technology to basically surface risk that is useful to a security professional when evaluating whether or not a specific AI component is safe, secure, or trusted. What I'm going to show you is an example of a live example, real data, of what we're starting to build that includes MCP servers. So I'm going to switch over to our very, very experimental view, and that needs definitely to be zoomed in. So very, very experimental view of our MCP server risk assessment. So we have about 600 servers that we've crawled through many different sources, but 2 of the bigger ones are the Smithery registry and then also the community MCP registry as well. What we do as well is also scan these MCP servers using both Snyk code, but also our MCP security scanning tool. So we're able to both show you any SAST issues that are found within the code of the actual MCP servers and their tools, as well as any sort of behavioral issues that we encounter through our MCP security scan. Here, we're basically just given a quick overview, including some scoring. The scoring is going to change. This view probably is going to change. This is very experimental. I just wanted to kind of give you a directional view of where we're headed. But the idea here is to make sure that we account for both the SAS side and also behavior side, but also the popularity, right? So if something is really popular but has security issues, those security issues matter a lot more, right? Let's take a look at one specific server, just to give you an idea of what data we have collected for it. For this, I'm going to be using Sentry right down here. You'll notice we've also imported the Smithery verification badge, where Smithery does their own verification of these MCP servers, but it's another kind of signal that we're giving to you to be able to figure out the trust part of it. Within the actual details page or the data that we're collecting, again, like the score that I talked about is up here, but we kind of divided into the key metrics side, which gives you an idea of the security posture around how many security issues, how popular it is, how many tools are being exposed to this server, but also the project health, which is more on the community side, right? In terms of popularity, in terms of how the maintenance record and what the maintenance community activity looks like, as well as how big is this community around this MCP server. And then down below, we have our security assessment, which includes both our Snyk code and our MCP scans. Again, like I can scroll all the way down through this, but you have an idea of kind of what we're trying to track, and then the information that we have for each issue is kind of summarized here. We're going to obviously make this look a lot better than this, but again, this is for illustration purposes, just to kind of show you the depth of information that we're going to be able to collect on these things. Again, just scratching the surface, one of the things to mention here is that we're also going to get to the same sort of level of information for things like models, data sets, and model providers. We're going to try and create this centralized risk registry place for you to be able to not just explore and interact, but also make sure that this is connected into the rest of our tooling as well. Really powering everything. Cool, yes, please.
Do you have a way to get an AI bomb for N8N or something?
Sorry, for?
Like a no-code solution, like N8N?
That's asking a product manager. We do have our human helpers back here who probably have a better answer for you. I'm not sure. I don't have the answer. The question is, do we have AI bomb solutions for N8N? No code solutions. I don't think we do at the moment. Yeah. I'm not gonna try and whip this at you. You can't blame that one on me.
I'm not a wide
Thank you. All right. So the next step on our climbing journey, now that we have found a bunch of components, we have some understanding of the risk, we want to also be able to test them. So I'm going to invite my jazzy voice colleague, Krish, to the stage to lend us his voice cords one more time and show us our red teaming demo to help you simulate real-world adversarial attacks.
Thank you very much.
Oh, I'll be back.
Okay, guys, I'm gonna do a demo with one hand in that case, but I'm glad I don't have to shout because my voice is totally gone. Right, so let's try that. Cool, so one of the things that we are releasing is a red teaming product, which is basically a dynamic application security testing product that uses an LLM to attack other LLM-based applications. So here I have an example application that is an agent. Sorry, actually that's not an agent. Coming back to my previous talk, it's not an agent. Forget about that. It's just a chat. So it's an LLM with a RAG. And I can show you that it works. Right, so it should, it's just an example vulnerable app, so you can kind of think of it as similar to something like OWASP, Broken Crystal, or whatever. We're gonna release it soon as a public open source repository. But anyway, I have this app, it uses LLM in the background. And now I want to test this app for security vulnerabilities. So Snyk has a red teaming CLI tool. It's part of Snyk CLI. You just type Snyk red team experimental. So I'm gonna type it right now, and it's scanning that up. I'm gonna walk you through the configuration file of what's happening here. So it's using this configuration. I hope you can see. So it's basically testing this SmartPal app that I deployed. I have it running on localhost, but I'm using ngrok to make it available publicly. So that's, again, shout out to ngrok. ngrok is an amazing tool. You can basically pipe your localhost stuff to make it available to the internet. So that's doing that. And yeah, so that's the URL you want to test. And then you need to tell the app, tell our red teaming app how to, basically how to pass prompts to the, to the other LLM. So you configure it like so, and then how to parse the responses. And then you need to configure authorization, right? So you have all of that. If you go to Snyk CLI documentation, it's available there, so it tells you how to configure it. So please go and check it out after the session, and it tells you how to configure. Anyway, so what that does, so it's actually, so it's running the scan now. So it's actually, there are 3 LLMs here. So there is an LLM that is the target LLM, or an application. There is an LLM that is attacking that LLM. And then there is a third LLM that is checking the output and thinking, okay, was that attack successful? So you have LLM on top of LLM on top of LLM here. So let me show you, because we probably don't have time to see the output. So let me show you the output of something I ran before. There we go. So I can. So that's the output of the attack. So I can show you very quickly what it's doing. So the attacker LLM will first try to figure out the capabilities of the application that it's trying to attack. So it's executing this capability extraction attack that is basically trying to poke the application and try to figure out, hey, do you have any database connected? Do you have any MCP tools if it's a agent, etc., etc. So it's sending these requests to the application, and it's getting the response. It's analyzing the response and sending another request until it manages to extract something. So in this case, actually, it managed to extract MCP tools that this thing is connected to. So that's the first thing it does, right? And then it learns that this application has MCP tools connected to it. Then it tries to exfiltrate the system prompt of that other application. So again, it's trying, and then in this case, it actually managed to do it on the first try. So it actually exfiltrated system prompt, right? So it kind of does that. It learns. It does that. It learns, and it's kind of going further and further. It's trying another attack, this time in kind of German English language. So that's one of the attacks that it does. It's trying to kind of map the language to bypass LLM safety features, right? It's trying to, what else? It's trying to do persona manipulation. So that's another technique that you can hack an LLM with. Like you convince it that here it's grandma or whatever, and then it's more friendly to you. So it will be better to jailbreak and extract system prompt, etc., etc. And finally, one cool. So it actually managed to do a lot of things. It extracted some PII. And it actually, at the end of the day, managed to execute some code. So it tried to, after it did all of this attacking and learned about the other application, it figured out that it can do a code execution attack, and it's trying to do a code execution attack. And at the end of the day, it managed to execute some Python code. So yeah, so that's just giving you a flavor of how these things work, where you have an LLM that is trying to attack another LLM, and as it goes, it learns. So you can see where it's going a couple of years from now when these things get better, where I think that's going to be the default way to attack any applications. So it's very exciting. Oh yeah, and the tool finished, so it gave the same output, just I didn't save it to JSON. Anyway, that's all I had for you today. Again, please go and check out our red teaming CLI. And then play with it, and yeah, try to hack your applications, LLM-based applications or agents that you're building with it. Thank you very much.
Thank you, Krish. Right, so you've seen a few different, give me a sec while this connects. So you've seen a few different tools that we've showed you today. You've seen the AI bomb, you see the red teaming, and you've seen the AI risk DB. How does it all connect together? They're disparate tools, right? I'm sure some of you are thinking, oh no, more tools. But the idea is that we can combine all of that in one place, and that's where Evo comes in. And Evo is our new AI security platform. It's really meant to centralize or operationalize AI security posture in one place and give you everything at your tooltips. And that's what we're introducing today. I'm going to take you through the UI. I'm going to show you some of the functionality. One thing I want to say is please keep in mind this is the very first version that we're shipping. We're going to be shipping this to a limited number of design partners where we're going to work with them to evolve it into the full vision that you may have seen released yesterday and then in our booth yesterday and today. Right, let's dive into it. Another live demo. Cool. Can everybody see this? Okay, I can probably make this bigger without breaking the UI. Is that all right? A little bigger. How about that? I think I heard good in the back, and the back wins. Cool. So what we have here is the EVA homepage. On the homepage, what we really strive towards is basically making sure that we're giving you the most pertinent information up front. And we anchor a lot of this information in traditional security paradigms, right? So we have issues organized by severity. These issues are created based on two types of policies. One policy, which is our own Snyk policy, where we have predefined rules that get evaluated for, let's say, MCP server scanning. And then you have user-created policies that allow you to also create your own posture and governance on top of what our scanners find to then create additional issues. We're also providing here some MCP scanning information, specifically coverage on the machine scans, the local machine scans, and then also what servers are found on those machines. A little bit about our MCP scanning. I can quickly show you some information. You can actually go to this GitHub link. I can make this bigger as well to see kind of how it all works. But this is an example of what happens on a locally deployed test where we're able to test locally for any of sort of MCP servers that have been installed on a dev machine. And you can kind of see as the scan is going through, it continues to verify or show you any of the issues that we're finding, things like toxic flow, et cetera. So that's a quick sidestep on what MCP scanning does. The other thing that we have done here is, in addition to the traditional anchors, such as inventory, which is basically where our AI bomb scans get stored, as well as our MCP scans, we also have the policies. In addition to these things, we're also providing you with an AI assistant, a chat agent that you can interact with on a daily basis. So just as an example, we can talk to it like a human. Sometimes it's scary how much these things feel like people. How can I best use you, for example? So what it does is it's basically trying to evaluate kind of what you're trying to get to, given all of the tools that it has in its backend. And what you're able to see is it'll tell you all the things that you can do with it. You know, maybe even my favorite thing. Let's see. Nope. See, we nailed the persona, just like a security professional. There's no sense of humor. A smattering of laughs. I love it. But yeah, I mean, you can then explore anything that you want underneath with your data, right? So for example, let's say you have a bunch of repositories tied in here with a bunch of scans, and you can say, for example, you know, show me the top models in my code base by count. And what it'll do basically is kind of reason about what you're trying to do. It's going to figure out what query it needs to run, and then it's going to show you a bunch of models. And it should not work because, of course, it's a live demo. And these things happen. What you should have seen there is a screen that lists all the models with the descending order of counts. Non-deterministic systems and live demos mix really well. Let me actually, I think I know how I can fix this. Give me a sec. When in doubt, start a new session. And right, there we go, bam. That's what we're going after. So again, you know, the possibilities here are endless. You're able to interact with this in any way you want. The idea here is, yes, you can see this information on the inventory page as well, where we have basically stored all of the assets that you're able to scan for using the AI bomb scan, using the MCP scan, and then you're able to filter in the way that makes sense for you, in the way that you want. Obviously, still early on, right? So there's a bunch of stuff that we're looking to do, including a more richer asset details page experience, and then obviously more richer support for these queries. One of the things that I kind of want to show you an end-to-end workflow here would be, let's say, for example, we want to go back to seeing like all the different models that we have, because maybe there's a model in there that we want to disallow, right? So let's say, okay, well, this is a model for the sake of conversation that I actually don't want to allow, that hasn't been vetted yet. So you can actually ask it to create a policy that disallows. And then what it'll do, again, is reason about what you're trying to do. It will think through, create the right thing that it needs to do, and voila, there's a policy. You can then quickly rescan, and it will understand it, even sometimes when I make solo mistakes, which is great. The beauty of LLM-powered apps. So right now it's doing AI bomb scans for all the repositories. It's finished, and one of the things they're working on is making sure this works even if the page doesn't need to be refreshed. But if I refresh the page, if I refresh the page, you'll be able to see that one occurrence, that one issue that we just created. And then in the details page, you can see more details around where all the different places in the code base where we found it, along with third-party information about who the manufacturer is at, what are the relevant URLs on the third-party side, et cetera. So again, possibility is endless, but this is one of the kind of the end-to-end workflows. As you can imagine, next thing that we're looking to do is think more about remediation side, right? So really closing the loop from discovery to connecting the risk DB information that you saw earlier in here, and then adding that remediation step that allows you to really close the loop on some of these things and introduce that governance, end-to-end governance. One last thing I'll mention about this before I invite my colleague on stage is instead of going through, right, for example, where you can see all the policies here, and then you can see all the issues, instead of kind of going through some of these prescribed experiences and static UIs that we have today in the world, you can actually just create your own. So let's say I wanted to say, show me only critical issues. I can now create the UI and customize the UI in a way that makes sense for me by basically saving this view. So if I save this view, give it a name, it will actually put it into the saved views section, where when you come back to this, it's a live page, right? So it's just like any UI page. So you can start to see how you can start to create the experiences that matter to you, so you're not constantly doing these explorations. You could just save these queries and come back to them later. For example, this page, if we add a new policy, it will list, and there's critical issues, it'll list issues there. If you add a new, or an existing policy finds new issues, they'll be updated here. So again, early days, but this is kind of the direction that we're headed towards. One last thing here is that we've added a couple of saved views just to show you what's possible on the MCP scan status and servers. And these are basically full lists of all the different machines and all the different servers that we find that are linked from the home page. So at this point, I'm going to ask Ellie to join me on stage and demo the Secure by Design part of Evo, which will be in the application side of things.
Okay, great. Can you hear me? Oh, it's working. What a pleasant surprise. So give me a second. Okay, I'm going to start while Krish is fixing that and is helping me. Okay, so great. Thank you, Krish. So as we said, I'm Ellie, and I'm responsible for the Secure by Design offering, okay? So this is actually our way of doing shift left to shift left, right? So we want to help build native AI application when you start building them, right? Even earlier than you're used to. And this is exactly what Secure by Design is, or you might be more familiar with that as threat modeling. So here you have the list of all of your applications, and you can drill down into one application, for example, AI application that we have. And this is actually where our story begins, okay? Let's try to zoom in a bit further. So what you can see here is the results of the AI bomb run. So right, you use your AI bomb, the tool that we provided you, and it helps us identify all the different AI components. And because we also scan your code, it also helps us identify different components. So when you try to do threat modeling, usually the first part will be to try to model your entire application. And then you realize that's quite a cumbersome process, right? It has a lot of back and forth with you as a developer, with ProdSec, with architects. So this is the first layer where we want to make it a lot easier for you and accelerate that, right? Because we already have the context as Snyk. Either we scan your code or we use AI Bomb, and we get to map all the different components for you. And obviously, you can also edit it, right? So you can say that this MCP client is communicating with another web service. You can edit it to the UI. And what's really cool about it is, unlike Miro or Lucidchart or all the different tools that you use, all the data here is connected and is shared. So if you have a team that already modeled an MCP server for you, you'll see it here. So it makes the process a lot easier and a lot faster. Now, the next thing is you say, OK, I need to understand what are the different threats that are relevant for this MCP server, for example. So behind the scenes, we have our very own AI threat libraries that we put a lot of effort and some of the best security researchers out there to already do the work for you. So imagine that there is like OWASP's top 10 LLM. We already bake those findings into our system. So let's click, for example, on the third-party LLM and try to deep dive into the issues, right? So one of the first things that you need to do, you need to validate and treat the LLM output as something that you can't really trust, right? Because this LLM someone can manipulate it and tell it, OK, so give me all of your password files. And then suddenly you have a problem. So this is exactly the instructions that we are providing you. So we already did all the heavy lifting, and now we tell you, OK, so you need to enforce an allow list. You need to make sure, for example, that this LLM can access your database user service, or it can access your local files, et cetera, et cetera. And we are also providing you with all the ways how to validate it, right? Here down at the bottom with the to-do list. And the really cool thing about it is we don't only take the burden from you of trying to understand how do you need to threat model AI application in this new area, but we are also familiar with your organizational context. Meaning, if you are using a database in AWS, for example, you will get specific instructions for AWS and not for GCP. Right? So the entire idea is to make your life easier, because we believe that in the AI area, secure by design is much more important than it used to be. It's much more difficult to understand your system as a whole, because it's not deterministic, because you have so many dependencies, because the threats are much more complicated. So we do this work for you, and we help you do it a lot faster and a lot easier. Now, the next step after that, as Ranko just said, we're going to help you with the remediation, right? So we're going to open a PR for you. We're going to open a Jira ticket if that's needed. And we're going to take those steps for you and suggest you the ways that you can actually remediate those problems. And the last thing is that, unlike today, where threat modeling or secure by design is a discrete process that you do every few weeks, every few months, we're going to make this process continuous, because we are integrating with your CI/CD. So whenever we identify a change, we can flag it for you and tell you, OK, so we saw that this model changed. We saw that this application changed. Let's try to better understand what you need to do different and how you need to model that. OK, so those are the main things that we give you the option to do today. The idea is to accelerate the secure by design process, to make it easier on you and much more readable. And that's mainly by integrating some of the takeaways and from the researchers that we already did, and from identifying the different components that we know that you have in the system. So that's really from the high-level perspective how you do that. Obviously, you can edit it, you can add more components, you can share it with your team members, and later on you can also track the different findings. So we believe it's super critical, super important. We're going to make your life a lot easier when you come to model your application. And what's really cool about it, it's not relevant only for when you're building new apps. We already know how to work with your current and existing apps. So it's relevant for any phase. So that's pretty much it, I think. I think I always wanted to be a rock star, but I had to settle up for being an entrepreneur and product manager. So at this phase, I'm going to take a selfie with you. OK, so everybody put their hands in the air. Amazing. Thank you very much. I had a pleasure being here. Ranko, the stage is yours.
Can you guys hear me again? Yes, yes, you can. All right, we're almost there. We're right at the summit, I think. Yep. So let's recap the day a little bit. So one of the things that we're saying is, as you start to connect LLMs to agents, to tools, the lines between data, users, the intent, it blurs very much, and it starts to create new risk surfaces. We're starting to see things like prompt injection, data exfiltration, too much privilege, right? Pop rears its ugly head. And honestly, like the way we're thinking about it at Snyk is the idea of visibility, the idea of risk validation and evaluation, the idea of testing and unified governance are really the ways to combat that. So what are some of the best practices that we can think about in this area? First and foremost, as Ellie just mentioned, threat model your applications. Secure by design is the way to go. As we know, LLMs are extremely unpredictable, right? They're non-deterministic, same input means different outputs. And we have to make sure that we're able to threat model and make sure that all the risks that are associated with modern applications are well thought out from the get-go, so you have a solid foundation to build on. Best practice number 2, as we talked, and my favorite, visibility. You have to have visibility into the risks and the components of those risks, into AI components and their risks to be able to actually secure it. And this is where AI Bomb and tools like AI Bomb can help you. So really, really, that is the foundation for everything that follows. And then finally, best practice number 3, test, test, test. There are lots of tools out there. We just showed you one as well today that allow you to simulate adversarial attacks, test your systems, make sure that's not done in production, right? Test before you go to prod, because the last thing you want is to learn after the fact. And of course, make sure that you centralize all of those needs in Evo as your AI security platform going forward. Right, so we're here, we're at the summit. Thank you, everyone. Try out AI Bomb today. It's available, as we discussed. And then, yeah, come talk to us if you have any questions or if you want to chat about anything else. We'll be around at the party. So I'll take it over to Ranko, please. Yeah, cheers. Cheers.
Test, test. Can you hear me? OK, I think it's on now. One moment. We're going to wrap things up real fast, and we're all going to get out of here and have some alcohol, potentially, if that's what you're into. All right, so I was going to say we have one more thing, but I actually have 3 more things, so I lied. First of all, I just want to do one more final round of applause for all the speakers today. Thanks. You know, one of the things they don't really tell you when you get into presenting is doing technical presentations takes a lot of work. So seriously, thank you all the technical speakers today. You did so much prep work, and it was so good, so thank you. Additionally, all of you who made it to the end of the day here, you should check your inbox right about 5 minutes ago. And you should have your certificate of completion, your AI Security Foundations course completion for coming through the entirety of the day, going through all the stuff. You've learned a bunch of things. I see some thumbs up going there. So thanks to all of you for coming. You can share those around. You can give them to your boss and say, you know, definitely give me a raise. Look at what I did. Stuff like that. It's valid currency. The second thing is we have this QR code on the screen. If you wouldn't mind, please take a picture of it on your phone or just pop it up for later. You don't have to do it now, but maybe you could do it sometime in the next 24 hours. Just let us know what you thought of the event. In case you're not aware, this is the very first time we're doing this event. So we're learning, we're iterating, and we are rapidly, programming our AI models behind the scenes to make this even better next time. So please take a pic of that. I'm going to give it one more second just in case anyone is waiting on the QR code. I'm trying to see, the light's a little in my eyes there, but hopefully everyone's getting it. Thank you. Thank you. Cool. All right, I think everyone has their hand down. OK. And then also big shout out to all of our sponsors. I'm not sure how many of you are in the room right now, but for all of you who are here attending, please go check out the sponsor products and stuff. They've been so amazing to work with. I mentioned this before, but I personally, as an engineer, have actually used quite a few of these tools and really, really love them. We have amazing people we work with. And then finally, the fun part. So we actually have a little happy hour kind of situation going on across the room. It's about a 2-minute walk, I think. So if you're interested in coming, getting together, and just hanging out for an hour or so, you can walk to the Golden Gate Tap Room. It's 449 Powell Street, so you might want to put that in your Google or Apple Maps. We're all going to head over there literally right now. Doors open in 5 minutes. So if you want to go and have a good time, you are more than welcome to come and hang out. And thank all of you for being here. So final round of applause for all of you. Thank you so much. Great. And, question, yes. Are the slides going to be shared? I will package the slides up, and we'll find a way to send it out to all of you after. Yeah, thank you. We did have some questions about that. Oh, and you might need to check your spam for the certificate, I was told, potentially. Not sure why, but double check anyways. If you have any issues, mention it to us outside in the lobby, and we'll get it sorted for you. All right, thanks everyone. Have a really great rest of the day. You're all amazing, and have a good one.